Have you ever wondered what lies beyond everything we can see? A place where the rules of reality simply stop making sense. A world where particles can be in two places at once, and where observing something actually changes what happens. Welcome to the mind-bending world of quantum physics, where the impossible becomes real and reality is stranger than fiction. Let's dive in. A world beyond imagination. There exists a world so strange that it defies everything we know about reality. A world where particles appear and disappear in less than a billionth of a second, where electrons seem to communicate across vast distances instantly and can even exist in several places at once. This is the mysterious world of quantum physics. No one fully understands it, not even the scientists who dedicate their lives to studying it. But curiosity belongs to all of us. So let's explore what quantum mechanics is, where it's used, and why it completely changed our understanding of the universe. The age of classical physics. For centuries, humans tried to uncover how the universe works. And then came one man who changed science forever: Sir Isaac Newton. In 1687, Newton published his groundbreaking book, Mathematical Principles of Natural Philosophy. With it, he explained the laws of motion and universal gravitation. He showed us that the universe follows predictable rules, that every object, from falling apples to orbiting planets, moves according to precise mathematical principles. For more than 300 years, Newton's laws defined reality. We could predict how high a ball would fly, how an airplane could stay in the air, or how the planets dance around the sun. The universe looked like a perfect machine, ordered, logical, and predictable. But then, scientists looked deeper, into the heart of matter itself, the birth of quantum mechanics. For a long time, scientists believed that everything was made of indivisible particles called atoms. But in 1897, J.J. Thomson made a shocking discovery. He found a particle even smaller than the atom, the electron. This marked the beginning of our journey into the subatomic world. At first, scientists imagined atoms as tiny solid spheres, with electrons moving randomly inside like raisins in pudding. But when they began studying light, something strange happened. When light passed through a prism, they saw not a continuous rainbow, but sharp, distinct lines of color, something that couldn't be explained by classical physics. This mystery drew the attention of great minds like Max Planck, Albert Einstein, Niels Bohr, and Erwin Schrödinger. They discovered that, in the world of the very small, electrons don't behave like planets orbiting a sun. They act more like waves of probability, unpredictable, invisible, and bizarre. The quantum leap physicist Niels Bohr believed that electrons could jump from one energy level to another inside an atom, instantly, without crossing the space between them. This became known as the quantum jump. When it happened, the atom would emit or absorb light at very specific frequencies, which explained the strange color lines seen in experiments. Einstein, however, wasn't comfortable with this new world of randomness. He believed the universe couldn't be based on chance. But quantum mechanics didn't care what made sense. It simply described how nature really works, even if that reality seemed impossible to our everyday logic. The double-slit experiment. To truly see the weirdness of the quantum world, scientists turned to a simple but mind-blowing test: the double-slit experiment. When you shoot tiny particles, like electrons, through two slits toward a wall, you'd expect them to form two bands, just like small balls passing through holes. But instead, they created a wave interference pattern, as if each electron had passed through both slits at once. To understand what was going on, scientists placed a detector to watch which slit the electron went through. But the moment they observed it, the interference pattern vanished, and the electrons behaved like ordinary particles again. It was as if the electron knew it was being watched. Observation itself changed the outcome. This is one of the strangest truths of quantum mechanics. The act of measurement changes reality. Superposition and observation. Before being measured, a quantum particle doesn't have a definite position. It exists in a superposition, a cloud of all possible states at once. But when we measure it, this wave of possibilities collapses, and the particle takes on one specific form. This means that at the most fundamental level, the universe isn't made of solid, predictable objects. It's made of probabilities, and observation decides which version becomes real. Einstein's challenge in quantum entanglement. Einstein couldn't accept this. He famously said, "God does not play dice with the universe." He believed something was missing, that quantum mechanics was incomplete. In 1935, Einstein proposed a thought experiment that revealed what he called spooky action at a distance. He imagined two particles that interact and then move far apart, even light years away, yet somehow remain connected. If you change one, the other instantly reacts, as if an invisible link exists between them. This phenomenon is now known as quantum entanglement. To picture it, imagine you have two coins. You flip them, separate them. One stays on Earth, the other goes to the moon. When you check the one on Earth and see heads, the other instantly becomes tails. No signal, no delay, just instant connection. Einstein thought this was impossible. He believed that the outcome was already determined from the start, like two gloves in separate boxes. If one is right-handed, the other must be left. But years later, experiments proved Einstein wrong. Particles really do stay connected across vast distances, instantly affecting each other, as if space itself can't keep them apart. What quantum physics tells us. After decades of experiments, one truth became clear. Matter behaves both as a particle and a wave. In the macroscopic world, our everyday world, we only see the particle side because our wavelengths are too small to notice. But deep down, everything, including us, follows quantum rules. The universe we experience is just one layer of a far deeper and more mysterious reality, where probability, uncertainty, and entanglement shape everything that exists. There is no real divide between classical and quantum physics. The quantum world is the true foundation of reality. And as we continue to explore it, we're discovering that the universe isn't built on solid matter, but on possibility itself. A universe that's alive, dynamic, and stranger than we ever dared to imagine. The deeper we look into the quantum world, the more we realize how little we truly know. Every discovery opens another mystery, reminding us that the universe is far more extraordinary than we ever imagined. If this journey into the hidden world of physics fascinated you, don't forget to like this video, subscribe, and turn on notifications so you never miss the next step into the unknown. Until then, keep exploring and remember, reality itself might just be an illusion,